Okay, welcome to this explainer. Today we are taking a trip to literally one of the most remote, unforgiving environments on the planet. We're tagging along on a mission where pushing human physical limits to the absolute edge is, well, it's basically the only way to unlock some absolutely critical, never-before-seen glaciological data about our planet's future. We're riding alongside elite climbers like Alex Honnold and glaciologist Heidi Silvestre on a totally unprecedented expedition in Greenland.
Okay, let's dive into this. To even wrap your head around the stakes of this mission, you kind of have to understand what it takes just to reach the starting line. First up, the team has to conquer the pool wall. This is an unclimbed 1,500-foot sheer rock face in the brutal Arctic. And man, the visceral terror of this environment hits you immediately. Hazel, one of the climbers, described the falling debris perfectly. She said it's like a little knife wound. I mean, a chunk of ice actually falls and strikes Alex Honnold right on the bridge of his nose, slicing him wide open. It instantly, and I mean instantly, proves the deadly stakes out here. If that had been a rock instead of ice, no way, it could have been fatal for sure.
So here is the audacious, almost crazy physical roadmap of the expedition. Step 1, climb that 1,500-foot pool wall. Step 2, cross the massive 42-mile-wide Renland ice cap. Step 3, navigate down a treacherous glacier to the ocean. And finally, Step 4, summit a colossal unclimbed sea cliff called Ingmikortilok. Surviving the rock face is really just the entry fee. Part 1, surviving the pool wall, fear, and teamwork. You see, surviving the crumbling rock of the pool wall isn't even the main event. Like I said, it's just the ticket to reach the untouched ice cap waiting up top. And the micro-narratives of this climb are intense. The conditions are absolutely grueling, freezing temperatures, rock that is constantly crumbling in your hands. It makes it incredibly tricky to secure climbing gear. So even for these elite world-class climbers, it's a massive mental battle. Because, climbers aren't just fearless superhumans. They actually have to learn how to manage intense, paralyzing fear through sheer practice. This was especially true for rookie climber Adam. He found himself terrified hanging out as the last man on the rope. But right before the climb, he spotted something crucial: 2 ravens. Now, in Adam's Greenlandic culture, this is a huge sign of good fortune. He says it gave him exactly the boost he needed. So when the team finally triumphantly hauls themselves over the summit edge after 2 brutal days, they honor Adam's cultural connection and the insane teamwork it took to get there by officially naming this brand new route 2 Ravens.
Part 2, the shift to science, entering the ice cap.
Once they actually make it up onto the ice cap, the team makes a massive structural pivot. They leave their heavy climbing gear behind and switch completely into a frontline climate mission. Basically, they're trading carabiners and ropes for serious scientific instruments. The spotlight shifts over to glaciologist Heidi. She is literally hauling incredibly sophisticated radar technology across the ice. This tech acts kind of like sonar. It shoots pulses of radio waves deep into the ground to measure the exact thickness of the ice and map out the entire subsurface terrain. She is essentially taking this 42-mile-wide, freezing, unmapped wasteland and turning it into a readable, highly precise scientific record. It's a real game changer. Now, as they're skiing across this endless, flat, white expanse, Haiti drops a truly staggering fact. The ice directly beneath their skis, it is 120,000 years old. Just let that sink in for a second. This ice has survived the last ice age, and even the period before that. They are literally walking over incredibly deep, ancient history. And because that radar reveals this ancient ice is over 2,000 feet deep in certain places, they're able to calculate its sheer mass. Are you ready for this? The Renland ice cap holds over 350 billion tons of trapped freshwater. And this brilliantly illustrates what 350 billion tons actually looks like. If this single, isolated ice cap were to melt completely, it holds enough fresh water to submerge the entire island of Manhattan under almost 4 miles of water. 4 miles! It visually anchors the mind-boggling scale of the threat if global temperatures just keep rising. Part 3, a frozen, melting minefield. So as the team attempts this long horizontal crossing, their progress just hits a wall. They're suddenly hit with absolute blinding whiteout conditions. I'm talking no landmarks, no horizon, just flat, blinding white in every direction. And in a whiteout, one specific hazard becomes incredibly deadly: a crevasse. Now, a crevasse is a deep, open crack in the glacier. They're often hundreds of feet deep and completely hidden by just a thin, fragile bridge of snow. The team checks their maps and quickly realizes they're walking completely blind, straight into a massive crevasse field. Actually, scratch that. It's more like a literal minefield of hidden drop-offs. So this forces a super tense, life-or-death Democratic vote. Despite Alex Honnold really wanting to push forward, the rest of the team votes to stop skiing, pitch the tents, and just wait it out, rather than blindly navigating that maze. But, Heidi, she never stops working. She actually uses this weather delay to grab a shovel and dig what she calls the ultimate snow pit. She digs a deep trench right outside her tent just to examine the snowpack. Now, she's expecting to find absolutely pristine snow up here. I mean, they're far north, they're high up in elevation. Her goal is to look at the layers of snow that represent about 12 months of recent climate history. But instead of pristine snow, she makes a really sobering discovery. She says the entire snowpack is crippled by these ice lenses. So what does that all mean? Well, an ice lens forms when snow melts into water, trickles down, and then refreezes into hard ice. Finding these lenses stacked throughout a 12-month cross-section absolutely proves that the ice cap isn't just melting in the summer anymore, it's melting year-round. It's an absolutely crucial, urgent reality that proves this ice cap is contributing to global sea level rise way, way faster than anyone anticipated.
Part 4. The fjord's climate reality.
Now, what's really interesting about this slide is the stark contrast in perspectives. The team eventually completes the crossing, right? But their descent down heavily broken, constantly shifting glacier is honestly just as nerve-wracking. They ski down to finally reach their support boats waiting in the ocean fjord below. And once they hit the water, the way the team reacts is totally split. For the climbers, it's pure joy just to be off the ice. They look around and see a magical, beautiful landscape filled with these towering icebergs. But to Haiti, it makes her absolutely sick. She says her heart shrinks. Because to her trained eye, these picturesque icebergs aren't beautiful at all. They are the sickening evidence of climate change. They're basically the bleeding wounds of a dying glacier actively collapsing into the sea.
And the stakes of that collapse are monumental. 24. That is the number. The entire Greenland ice sheet contains enough frozen water to raise global sea levels by a catastrophic 24 feet. As Heidi bluntly puts it, this is our future, and it's also our demise.
But listen, they aren't just sitting there observing the destruction, they are actively working to understand it. Right before they head off to their final climbing challenge, Heidi facilitates the climax of the scientific mission. She launches probe 9317 for NASA's OMG project, which stands for Oceans Melting Greenland. This little robotic float is going to spend a full year going up and down the water column, measuring salinity, recording temperature, and tracking depth. It transmits this data daily via satellite to help scientists understand exactly how the warming ocean is destroying these massive glaciers from the bottom up.
Part 5. The ultimate challenge awaits. So, the science is successfully deployed, the data is secured, but hey, our explainer doesn't end here. We've got to pivot right back to the extreme sports stakes because the team's most impossible physical test is just now emerging from the mist about 30 miles away, Ingim Kortilok. This is a 4,000-foot, entirely unclimbed sea cliff. It is literally 3 times higher than the brutal pole wall they barely survived at the start of the trip. The climbers describe its profile as looking downright evil. I mean, it's a final boss so incredibly massive and remote that it humbles even the best big wall climbers in the entire world. They look at it, and honestly, for the first time on this trip, these unstoppable athletes look purely human.
And that leaves us with a really profound thought to end on. If humans, armed with nothing but teamwork, courage, and a bit of rope, can conquer an impossible 4,000-foot wall of crumbling rock, well, can we apply that exact same audacity and drive to save our planet?